Okay, so method 2 is looking at algebraic juggling. Okay, so we're trying to see how many times x squared plus 3x plus 5 can be divided by x plus 2. So in other words, we're trying to see what can we multiply x plus 2 by to get the numerator x squared plus 3x plus 5. Okay, so we take a term at a time and we say, what can I multiply x plus 2 by to get x squared? Well, we know to get an x squared term, if this x part of the term is multiplied by x, then we would get our x squared. So we write that down. X times x plus 2 will give me the x squared part to begin with. Okay? But because I'm trying to keep it balanced, it's an equation, I have to keep it all over the same denominator of x plus 2. Now, not only does that give me the x squared, which is what I wanted, it also gives me 2x. Okay, but if we check, we don't want 2x, we want 3x. So how many more x's do I need? I need 1. Okay, so I've already got 2x from this term. To try and get 1 more x, again, what would you multiply the denominator by to get x? Well, because it's already got an x term, we would just multiply it by 1. So I can say plus 1 times the denominator. And again, to keep it balanced, I keep it all divided by the denominator. Okay, so I double check, I've got my x squared, I've got 2x, I've now got plus another x, which gives me the 3x which I'm looking for. So we're nearly done. This term here, when I multiply it out, also gives me a plus 2. But if we look, we want plus 5. So how many more do we need? We need to add 3 more to get from 2 up to 5. Again, what can I multiply the denominator by to get 3? Well, we know that we can't do that because we've got an x term in the denominator. And 3 is a constant, which is a degree below the x. So we cannot use the denominator in this case to multiply to get 3. So what we say is, right, we're trying to get 5. I've already got 2. So at the end, I can just put plus 3. But again, to keep the equation balanced, I have to divide through by the same denominator. Okay, so I double check, I've got my x squared, I've got 2x plus an x gives me 3x, I've got a 2 and then plus a 3 gives me the 5 which I'm looking for. And if we then look, what we can do is we can cancel the numerator and denominator of both of them. And then if I tidy that up, I'm left with x here, I'm left with 1 here, and I'm left with 3 here, but the 3 is still being divided by the denominator because there's nothing that cancels there. So that's my final answer. So just to go through algebraic juggling again, you're trying to see how many times, just like division, how many times the denominator divides into the numerator. So you take the numerator a term at a time and see how can we use the denominator to get that term on the numerator. So we know that if we times the denominator by x, that will give us the first term of x squared. To then get the next term of 3x, we might want to say, well, we could just do 3 times that. But we have to take into account what we already have here because from this term we already have a plus 2x. So instead of multiplying the denominator by 3, I actually only need 1 more. So that's why I multiply it by 1 here. So when I multiply it by 1, it gives me the extra x to make it up to 3x, which is fine. And then my final term that I'm trying to get is plus 5. And we know that to get a constant, we can't use the denominator this time because it has an x squared. Okay, so we would be tempted to just put plus 5 at the end and again still divide through by the denominator to keep the equation balanced. However, because we've already got a constant of 2 here, we only need another 3 to make it up to 5. So we can say plus 3 and again divide by the denominator to keep the equation balanced. I can then score out my numerator and denominator from the first two terms, leave me with x plus 1 plus 3 divided by x plus 2.